Good morning, everybody. Today I'm going to talk to you about OpenAPI and JSON Schema, and how you can use it to leverage, how you can use it in a lot of ways to kind of unify how you describe your services, but all the other things that you send messages across your architecture. And a little bit about me: I'm a principal platform engineer at ONA. I've been in the Plum community. I co-authored an open source web framework or REST API data framework called Guillotina, and I've done a lot of Python async IO lately. And at ONA we do like almost all Python, a lot of async IO, and ONA is a knowledge integration platform. And so yeah, we collect a lot of data from a lot of different places and allow you to search through it and manage it in different ways. And some of the goals of this talk are going to be, an introduction to OpenAPI and JSON Schema, and hopefully convince you of why OpenAPI and JSON Schema is superior to other ways of describing your services, and how it can be used in different ways up and down the stack. So what is OpenAPI? It's basically just a way of describing your APIs. It doesn't have to be REST, but I mean, it's meant for REST APIs. The basic level is like some metadata on your API. It's just a standard for, and it used to be called Swagger too. It kind of got transitioned into an open standard. And this is like the basic of server URL and some descriptive language on your API, and then you can describe your paths. In this case, maybe like users, and then the request body here is an example of like what kind of payload should your API accept. And in this case, this is a description in JSON Schema. So that's why we're going to talk about JSON Schema with OpenAPI, because they kind of they work together to describe to allow you to describe your APIs. And it's pretty expressive. You can do most things that you'd want to do with an API. You can describe parameters like this, query parameters in your API, and you can describe the responses that your endpoint should return. And even in your responses, you can reference other object definitions. So like you don't have to like describe every single like field type in your response. You can reference another object that's described somewhere else, so you can be more succinct. And then also give example data too. And this is in YAML. It can be YAML or JSON, but most of the OpenAPI examples are done in YAML. And then so after you have this API described, there are things like Swagger UI and Redoc that will be able to read OpenAPI and also give you a UI to explore and to test out the endpoints that follow these standards of describing your API. And so what is JSON Schema? JSON Schema kind of looks like this. So if you have a JSON payload that has first name, last name, and age, it can be described as an object and has properties, first name. So the properties keyword is all of the properties that should be inside your JSON object. And then they each have a type that's described with them. And so like libraries that implement the standard would just need to enforce this way of describing your JSON data. But it's pretty simple. It has a lot of additional features. Like it can start out simple, but you can pretty much describe anything you can imagine. Arrays can have sub-object types. And so here's an array type, but its sub-items can reference another object. But you can do lots of nesting. You can min max. There's all kinds of different constructs to describe your schemas. And I haven't had a situation where I couldn't describe what I wanted to do, unless it wasn't JSON. Maybe sometimes it can be more difficult then. But so before we go more into, I just want to kind of describe like the history of what we had before JSON and why we are at JSON, why you should use JSON schema and OpenAPI as opposed to maybe something else. And, oh, sorry, went the wrong way. And so before JSON, we kind of had XML-based ways of describing structured data. And maybe some people are young enough to not ever have to deal with XML, but if you deal with HTML, which everyone has to deal with, it actually stems from a base standard called SGML, which is quite old. And I couldn't really find anything that was apart from XML, like in history, that was really used very much. But anyways, it's quite an old standard, and actually, like, so older, I don't know if Python standard library has an HTML parser anymore, but it used to be called an HTML parser. Like, so some of the stuff like really has quite old roots, and but XML and HTML have the same roots in SGML. And from that stemmed like things like XML RPC and SOAP. You have like XSLT, like transforming XML into different XML, and XSD for schemas. So a lot of things around XML came out, and XML kind of looks like this, nested, maybe a little bit more verbose than JSON. But you had this thing called XML schema, which could describe complex types as well, and then you could validate those complex types. And you had a thing called SOAP, which was a way of describing entire services that you could then use like generators that would create objects that would call these services through, that were defined in XML. And there was even XML databases, which is crazy. There's a lot of them. And so you would store XML documents that were like validated against XML schemas in your database. And those were somewhat popular, I guess, but it's pretty interesting. And then came JSON. So XML kind of finished a lot of its standards in the early 2000s with SOAP and XML schema, and JSON kind of came around in the early 2000s as well. And it was officially standardized in 2013, but it's actually stands for JavaScript Objects Notation, and it was around like representing JavaScript objects as a string. So like the syntax and everything looks really similar to just JavaScript objects. And so it plays really nice with in the JavaScript world, obviously. There's tons there. Right away, there was a lot of JavaScript libraries because it's a pretty simple, like they don't like support complex types. And that's why JSON schema can be useful, is because you can use the schema, use JSON schema to help describe more complex types. And it's plain text, which is awesome. So you can easily introspect it. And for a long, like Python has really nice, simple support. It's really easy. In Python's case, it maps really nicely to dictionaries. So it feels really nice. Like it does feel really nice to work with in JavaScript. Some, like maybe if you're in the Java world or any other kind of strongly typed language, might be a little bit more cumbersome, because you might have to like define classes that represent your objects, and then that's what's used for serializing and deserializing. So with the advent of JSON came along JSON HTTP APIs. And in the early days of JSON HTTP APIs, like there weren't really any standards to describe them. And people were still using form encoded data for the request bodies. So it wasn't like you didn't have any, so it wasn't like the API was accepting JSON body and then outputting JSON body. It was like accepting form encoded data and then outputting JSON data. And so there's a lot of different mapping that you do from schemas to database columns. And it didn't always work out very well. Like if you can remember, even multi-part form encoded data is really ugly stuff. You'd have these things like the request body would kind of look like this, and all of your data would be encoded in these boundaries to that needed to be parsed. Especially for larger data, it was really cumbersome, and then you couldn't really inspect it. And how are you supposed to describe this in any sort of API? It's And we had all kinds of like Python libraries around just producing forms and parsing forms and then translating data into and out of forms. I mean, I guess this is also in the days of where most developers didn't wrote backend code along with the JavaScript code and rendered the forms in HTML. And so it was like a different type of way of engineering for the web. But you'd have all kinds of things that you needed to translate this form encoded data into complex objects on the Python side in order to parse it correctly and validate it. But now with now that JSON's getting more popular and JSON APIs are getting more popular, people are building APIs that actually accept a JSON payload. So now instead of doing form encoded data, the data that you're sending is JSON right there. So with that, you can validate it against the JSON schema, and so you can have like sort of a unification between a request and response. And so we use the same content with request and a response. We're not wasting time with form libraries. And we play nice with front-end developers because they can consume these JSON schemas and OpenAPI specs as well. And yeah, really good. Everything can be validated up and down the stack, and we have sort of a unification. And this is just a tangent, something that's bothered me for a while. So like, it's kind of silly that we, like I described how the form encoded data is not very nice to work with. But Stripe, which is a company that sells an API primarily, accepts form encoded data and outputs JSON. They don't accept JSON payloads. And they actually have to do nested structures in their form encoded data too. And they have to describe it differently instead if they just accepted JSON payload. But they haven't for a while. It's just kind of interesting that they haven't been able to change their stack. So what might this look like in practice? This is an example of a library with, it's called FastAPI. FastAPI leverages this Python library, which we'll talk more about later, as well, called pydantic. And so pydantic, you can describe Python objects that also output as JSON schema. And so you can, so in this case, our add user, our add user function is an endpoint at /users, and it accepts a body of user. So this type right here. So this will be a JSON schema type that describes an ID as a string and a name as a string. And this is just a really stupid API, but we're just adding users to the list, and getting a user is just getting it by ID. There's no error handling here or anything. It's just dumb example. But in this case, this is the user ID is describing the user ID in the URL path, and returning the actual pydantic object. And that pydantic object is serialized automatically to JSON. And we have the pydantic speaks JSON schema, and FastAPI can output all the JSON schema and endpoints into OpenAPI definitions. So we automatically have everything, payload and response bodies described in JSON schema and OpenAPI, and we have all the validation and serialization. So we're not spending time serializing back and forth or into any other format, and yeah, it works. It's really simple. So our payload looks like this. Our data is ID foo, name foobar, and it validates against that pydantic schema. And when we get it back, it outputs the JSON. And then for free, in these sorts of frameworks, FastAPI is the one that makes it like the most simple, but like there's a lot that do this. You get the OpenAPI spec, and it describes the request body as this reference object, but it's described in the schema, and you get a Swagger UI to inspect the API, and you can try it out. So JSON, so JSON's also coming for your database too, right? I mean, almost all the new databases that are coming out, that have come out in the past 10 years are JSON document storage databases. And so why not use JSON? If you're using JSON for your APIs, using JSON on your front end, you're using JSON to validate schemas, why not use JSON in your database, right? And even in your relational database system, where we have JSON, you have JSON fields where you can actually, in Postgres, and I'm not sure if MySQL, I imagine you can too, but in Postgres you can add indexes on nested JSON document fields. And if you don't need indexes or anything like that, you can also just do text columns. So why not just, if you can describe everything in JSON, why wouldn't you use JSON in a relational database system? Well, maybe for indexes, certain types of indexes. I don't think Postgres works with JSON fields. And if you had to do joins across tables. But and it just kind of makes me think of like, why are like so many times engineers are just like wasting their time like mapping data between different systems. It's like we describe a form, that form needs to be translated into a database set of columns, and those database sets of columns maybe also need to be translated into JSON schema. It's like, why are we wasting our time with this? And unless we need some of the like strong typing in the database, which maybe you can do it with JSON schema instead. Why are we wasting our time like serializing and deserializing and mapping data between different types of components? Being an engineer, don't be a data mapper, serializer, deserializer. Yeah, so with the advent of databases, at least originally when people were using it, like they were just throwing lots of stuff in these databases. And so like JSON schema provides a nice standard for you to validate all the data that goes into your JSON database storage. And there's this really simple JSON schema package that allows you to define a schema and validate your objects against it. So it could have very, very simple integration before you stored anything in JSON schema to make sure it like validated against some schema that you're deciding to describe for that payload. So with all that, you have a really nice service-to-service architecture for describing how services should communicate with one another. You have and so you have it all the way up and down the database layer, and but that also, if we're talking about service-to-service communication, like why aren't we thinking about gRPC? So I'm going to spend a little bit of time also talking about gRPC, because I think if you're going to talk about this subject, people are going to wonder, why wouldn't you use gRPC? So gRPC is this, it's called a Google Remote Procedure Protocol or whatever. And it's something that was developed by Google in 2000, I'm sorry, I keep screwing up with that. In like 2001 originally, and they've been trying to push it for a while. It's built on what's called proto-buffers. It's this way of describing objects, and in this unified way of describing objects, and then every single language needs to compile this definition into like Python objects. And then you have a serialization, deserialization framework between Python between payloads and those Python objects. So it kind of looks like this. You have these numbers 1, 2, 3 are kind of like slots. So if you change any schemas, it won't affect like data that was stored previously. And you're supposed to always augment the numbers, something like that. And gRPC is like sort of an augmentation of the protobuffer definition language to also define like services. So this is like akin to like defining a service in like a SOAP, in SOAP, like the XML SOAP. This is like defining services, not defining services, but describing services with this protobuffer language. And so like each of your implementations would, like, if you were going to say that, hey, I'm going to like implement this service in Python, you'd have to implement the service according to these return types and everything, and then you'd be able to communicate with other languages across this language, across this definition. So like, as long as everyone implemented it according to the typing, then you should be able to communicate properly. Yeah, so it's initially released in 2001, and Google started pushing it harder in 2008, around 2008, and almost all of Google services have gRPC type layers that you can interact with. And yeah, I said it was pushed by Google. Let's keep going. Yeah, so it's compiled though. So every language needs to compile it, and it's a little interesting too, because you have some languages that have multiple implementations of it. So you don't have like necessarily a standard way of converting the protobuffer objects into your language destination. So like, I think in Rust, there's a bunch of different implementations. There's multiple implementations for the service implementation for sure. And there's no actual evidence that, at least it seems to me, the things that I've tried, there's not much evidence that gRPC in itself is faster. It's supposed to leverage HTTP2 in order to do like asynchronous communication, but that, and you'd be able to do like push type, like where you can just push data to another service proactively instead of waiting for it to request it. But it's unclear how some of those features can be utilized in the gRPC way that has much more advantage over standard like REST APIs. And it's a binary format, so you can't even like inspect the calls very easily. The tooling around understanding what's going on when you're making the requests is not great. There is a couple of tools that now you have available to you, but it's not as easy as HTTP. And the Python driver has not been great for a long time. There was no, it's for a protocol that's really meant to be asynchronous. There was no like async IO support until like very recently. And it's actually really slow. Like if you're doing anything that has some sort of more complex object in it, it's much slower than just doing JSON. And there's not really any databases that speak protobuffer. There's one that I could find, and the fact that it's called Profane makes me wonder, because and it's still very development. But if you can imagine, if you have to compile every single model, that would make it a little difficult in a database type way of describing things if the database itself had to compile each like protobuffer model in order to store it or to be able to understand it. So why would you use it? I don't know. Like I think the simplicity of HTTP APIs and REST and JSON schema and OpenAPI is much better than gRPC, and so it's just my little shtick on be wary of gRPC. I don't know if it's as good as what Google wants you to think it is. And so back to OpenAPI and JSON schema. So why is it better? There's no compilation. You can like do things dynamically potentially with JSON schema. It's plain text, so you always can like understand what's going on. Their APIs very clearly. And I already talked about HTTP. I don't know like if gRPC really leverages it any better than plain REST. And you can like unify like your REST APIs across all the way down to your database layer, and you can stop wasting time mapping data. Yeah, I think simplicity basically is why OpenAPI and JSON schema are much better. And then with web frameworks, if you use OpenAPI and JSON schema to describe things, you always have a single source of truth. And your documentation is always up to date, because if your schema is, if how you describe your application is what drives your output for your documentation and your Swagger UI and everything, then you always have a source of truth that is what's tested against, and your documentation is always up to date. You don't have to manually curate OpenAPI docs. So if we look at the fast API example again, this is just a Python object, and you get type checking, and it's really easy to write tests against this. And it's and it automatically any changes to schema or anything like that automatically updates all your documentation, your Swigger UI, and your spec. And so Fast API is one framework that has full like first-class citizen support for OpenAPI and JSON Schema, and so does Guillotino, which is the framework that I wrote. But you can describe your JSON, your OpenAPI spec right with your service definition, and it automatically exposes those as well and validates it. And other web frameworks have some support for an OpenAPI. Pyramid has one. I think the Pyramid, or actually Pyramid has a couple, but the one that's more popular, I think you actually start with the OpenAPI doc, and then it validates against your endpoints. And then Django, I think the REST framework one does have it as well, but they used to support this other standard called Core API, which they're moving away from now. And there's some for the other ones too. There's this API spec library that will generate API specs for different frameworks. And I just have another tangent that I thought I'd go down. Before you consume libraries, I would suggest you read them and understand what you're getting into. So if you pip install it, you bought it, right? So like you have to support it, and you have to like you have to be able to debug it if anything goes wrong within it. Open source isn't completely free, right? You have to, what you're consuming, you pay for in some way. And I just have an example of trying to read some of the protobuffer protocol for parsing time zones. And when I was like, at one point in my life, I spent some time inspecting performance of these different formats of like protobuffer versus JSON schema versus this other one called Cap'n protocol, which is actually really fast, but it's binary still. But anyways, this one, I was trying to figure out why Python's protobuffer implementation was so slow, and trying to do just time zone implementation in protobuffer in Python was kind of ridiculous. So anyways, read what you're consuming and understand what you're getting yourself into. Also, against too many libraries, another tangent, but this is just actually a screenshot of JavaScript. You know, if you do a standard install of most JavaScript libraries, you end up getting about like thousands of JavaScript packages. And there's tons of these packages, and it's just kind of comical. And now you've bought all of these libraries that you have to potentially support, when maybe you could have just, like, if you were using one of them, you could have understood it and copy and pasted the code, and now you know how to do that, how to like write that little piece of code maybe, or you've learned something and you can support it. But instead now you're just learning how to support a whole bunch of other people's stuff that you don't know and you haven't read. And so we've done a couple examples with pydantic. I just want to show like how useful pydantic can be. You have it's a really simple way of describing Python objects. You have full JSON support where you can export it to JSON. You can parse raw JSON objects and it will give you a model instance back. And then you can export this JSON schema directly as well. So you have everything that you need related to JSON schema objects in serialization and deserialization right in pydantic. And you have type hinting and mypy validation. So like a lot of really great stuff with pydantic, and it's a nice library to look at. And so if you wanted to support, so it's like I was just railing against having too many libraries, right? So if you wanted to support JSON schema validation and manually, and this is like a pyramid example, you could do kind of what Fast API does, and with like the pytest kind of injection of parameters in your function. So this case, this is an example of that add user API endpoint, and it's taking the pydantic model as an argument, and then we're adding a view. So like, how could we make that work? This is just adding, this is regular pyramid type adding a view to this route. So /users will work. So this is a decorator. So I'm sorry, if we look back, I'm using this @API decorator. So the implementation of that is just using Python's introspection, Python's introspection library for inspecting the function, and this would be the endpoint function. And we're looking at all the parameters, and we're looking at the annotation on the parameter. In that case, the annotation was that pydantic type, and we're parsing the object, and we're using that as a parameter in that endpoint, in that function. So we have really simple, like kind of fast API implementation. It's going to be doing, I mean, there's not error handling here. You're going to have to add error handling and everything for if the payload didn't parse correctly, but you get JSON schema validation, and you can imagine also being able to iterate through all of your endpoints to describe all of the endpoint, to be able to like create your own API spec to, instead of having to consume a library or something like that. But anyways, it's just an example of how you can write it yourself. It's not too hard. So what are some additional use cases with JSON schema and OpenAPI? If you're sending data into message queues, it makes sense to also validate all those messages against the JSON schema. So anything with like RabbitMQ or Kafka or whatever. And so you can just validate with JSON schema directly, or you could use something like pydantic to serialize and deserialize as well. You can also validate so if you use Docker at all, or use Docker with like Kubernetes or anything, you're always sending in configuration as environment variables, and you can validate those environment variables with JSON schema. So you can describe the acceptable environment variables that your Docker container needs to have to operate, and then validate them. There's a library called JSON Schema Environment Validator that you can look at. It does it. It's pretty simple though. It's just like looking through all the environment variables against a JSON schema definition and pulling them out and validating them. So now we have JSON schema everywhere. We have it in configuration. We have it in our models, in our code. We have it in our database schema, and we have it in our message queues and documentation. And so up and down the stack, we've described most of the ways that we map different data with JSON schema, and we're all happy, right? And some other things that are useful is OpenAPI spec validator. So you can validate your final OpenAPI spec. And then there's also a package called Freddy, which generates data against which generates fake data based on JSON schema or pydantic models. And yeah, that's kind of it, guys. I think I just got it in time. Do you have any questions?
That's perfect.
Nice.
Yeah, sorry, my Zoom just minimized all of a sudden. We actually do have a few questions. David asks, any thoughts on how to avoid needing to define types twice, once in a Python backend and once in a TypeScript front end, and keeping them in sync?
Yeah, I mean, there's a couple of things. You can provide like a schema API server that just is like a central source of truth that store all of your JSON schema definitions. Or you can, like, as long as your OpenAPI definition is live and you're powering your OpenAPI definition from your schemas, like your front end can also consume the schemas there. But you're also, if you're talking about models that are defined, like say in TypeScript, then it's not like you can easily sync those. There are, I know like some people have really like Rust, because you can define Rust types that interopolate between TypeScript and Rust. I don't know, that's just an idea. But if you want like type checking in like say TypeScript, then those are defined in files, and that's harder to sync. I don't have anything else besides a more dynamic approach for you.
Is there a Git repo for this session?
I don't, but I guess I could throw some of my code in a Git repo and share it out if people are interested.
Mm-hmm. Yeah, for sure. If you do end up doing that, just throw it in the Slack. Cool. That track 3 channel, that should be perfect. And then what are the main downsides of using OpenAPI?
Main downsides. I mean, well, I guess if you have, there are some cases where OpenAPI can't describe like dynamic paths, like traversal type APIs. It's harder to describe. So in Guillotina, that API that I had mentioned, it's actually a dynamically pathed API. And so the way we've dealt with it is that every dynamic path has its own Swagger, dynamically generated Swagger and OpenAPI definition that you can request. So those are the main, I guess that's one big downside, is for some like traversal based dynamically pathed APIs, it doesn't describe very well. But otherwise, I'm trying to think of main downsides. Yeah, I mean, it can be verbose, and maybe sometimes if you get errors, it's hard to understand what you've written wrong. And I personally like really despise YAML, and a lot of the tooling around it encourages YAML. And so maybe you'll get issues related to YAML. I don't know, like indentation or something like that.
Sure. Do you have any more questions? I'm looking over here in the Slido and the Slack as well. Here we go. Do you know a good library to create a Swagger doc in Django?
I don't use Django very much anymore. So I can't really tell you. And I guess I wouldn't say like you're not creating a Swagger doc. You're creating an OpenAPI spec, and then Swagger can consume that. So I had listed like there's the API spec package, which is supposed to be able to consume different. I don't know. I would look at that and see if it can. The OpenAPI spec package is supposed to be able to take different frameworks and translate their definitions into OpenAPI files. I would check and see if that would work for Django. Otherwise, I don't know for sure.
We're about to run out of time here. Nathan, if you're willing, we actually have some galleries where people can kind of join like a little bit of a Zoom session. And if they have any other additional questions, I will throw that in the Slack, or you can just hit the gallery button if you're in Loudstorm right underneath the video. Nathan, thank you so much. Really appreciate you being here. This was super awesome. I give a round of applause from me. You probably can't see everybody else, but I know that they're clapping as well.
Right.
Yeah, thank you so much.
Right. Thanks, guys.